I'm Kelly Sullivan. So today we're going to be looking at area models and how they grow throughout the grades. They start by using them for multi-digit numbers and multiplication, and then throughout high school, they build on that foundational knowledge in order to multiply polynomials. And lastly, we're going to see how to factor a trinomial using the same method and find the binomials that multiply to get that. So we're going to start with question A. In a story of units, students compute 15 times 13. So we're going to start with something we know, multiplying 15 times 13. And we're going to start by drawing that rectangular array. So on your papers with question A, you guys can draw this. And once you draw it, I want you guys to take about 30 seconds and just talk with each other. Why do you think we set this up in this way? So once you have it drawn, why do you think we set it up like that?
These are the ones. Tens and ones. Add together. 13.
So can I have one person share? What do you guys think?
They are separated by the tens and the ones.
All right, so if we look at this, we have 10, and then we have 5, and if we look at the length of that rectangle, we can add that together to get 15. Same thing on the side, 10 plus 3 gives us that 13. So in a story of units, we break up the numbers just like you guys did in order to make it easier for the kids to multiply. It also helps to clarify the distributive property by generating these partial products, which are filling in these rectangles, finding the area of those rectangles, and then finding the total for our final answer. So what we're going to look at next is finding those partial products. If I start in the top left rectangle, I'm going to take the length, which is 10, width, which is 10, and I'm going to multiply it to get the area. What's that going to give me? 10 times 10? 100. And then we fill it in for the area of that. That's one of our partial products. Then we're going to move on to fill out the rest of those. This rectangle is 5 times 10. That gives me 50. Bottom left is 10 times 3.
30.
And bottom right is 5 times 3. 15. Once we have all of these partial products, we just need to find the total, so we're going to add all of those numbers up. We have 100 plus 50 plus 30 plus 15. I'll give you guys a second to add those together. Do you have an answer? What do you got? 195. 195. Awesome. So as we move up through high school, we use the same method in order to work on more complex multiplication, like multiplying binomials. In a story of units, we use this rectangular array to multiply multi-digit numbers. In a story of functions in high school, we use the same type of method, but we call it the tabular method, in order to multiply these two binomials. And the only reason we really call it the tabular method instead is because we incorporate negative numbers, and if we're thinking of a rectangle, we can't have negative measurements. So we're going to look at part B next, and we want to set it up the same exact way. So we're going to draw that rectangle again, and then we're going to place the numbers the same way, or the terms of the binomials the same way we did last time. So in B we have x plus 5 times x plus 3. So I'm going to take each binomial and separate it. I have x plus 5, x plus 3. Kind of the same way we did that 10 plus 5 and 10 plus 3 in the last problem. Once we have it set up, the next thing that we need to do is find those partial products. So the same way we multiply the numbers in part A, let's see if we can fill out or find those partial products. So take about 30 seconds, fill those out, check with your other partners. Good, good. Carrie, can you just read out what you got?
Top left is x squared, top right 5x, bottom left is 3x, bottom right is 15.
Awesome. Once you find your partial products, I want you to look at those and what do you notice about the diagonals? So if I'm looking diagonally from top right to bottom left, what do you notice about those?
The degrees are the same on the diagonals.
Right. So this helps students out because it gives us the like terms. And then the next step we're going to do is take each of those diagonals and total it up along the outside. So this only has one rectangle. So it's going to be x, sorry, x squared. Along this diagonal we have 5x plus 3x. So I can combine those, that gives me 8x. And then lastly, this only has 15. So I have 15. And then my last step would just be to take all of these and put that into the trinomial for my final answer, which would give me x squared plus 8x plus 15. Before we move on to the last one, I want you guys to just take a look at A and B, both of the problems that you guys did. What do you notice within like the coherence between them? What's kind of the same? What connects? What will help students kind of make connections between these two topics?
When you use the 5 and the 3, and then a similar term with the 10's match, the x's match. So it's set up the same way, so they'll make the connections between them.
Right, it's totally set up the same way, and just like Carrie, you notice if I replaced the x with 10, or substituted the x with 10, I would end up with the same exact answer because it's the same exact process. Anything else? That's pretty much it, right? The big process is exactly the same. You multiply to find those partial products, and then find the total by adding those together. Part C is going to be a little different. We start with the trinomial, and we're actually going to see if we can work backwards in order to find the numbers that it starts with. So I want you guys to start. I'm going to do it up here also. See if you can set up your tabular method, and see if you can just place that trinomial where it should belong. And we know we need to set up that rectangle first, but what is going to be different in our setup here? We see that minus 15, and we're starting kind of in the opposite end. We're starting with our answer that we got in the last one. So I'm going to have numbers out here first. Let me just make sure I have the right numbers. X squared plus 2x minus 15. Since we're starting with that trinomial, we need to kind of work backwards for that. If we think about what we did to get to this point, we added up those diagonals. So what partial products can I fill in just knowing this information?
The x squared.
Right, this only has one rectangle with it, so I know that this has to be x squared. Which other one?
Same thing with negative 15.
Right, same thing with the negative 15. It's only one of the partial products, so I know that those numbers have to go there. And then you're going to keep working backwards. If I know that this partial product is x squared, I can start to find the terms of the binomials that I need. X squared, if I break that up, what terms am I going to have here and here?
X and x.
X and x. So I have one of those, and now I need to figure out these other two. Thinking about what is going on with this, I know I need two numbers to multiply to negative 15, and those same two numbers I need to add to get to that 2. So I can start with the factors of negative 15, but I have multiple factors of negative 15, right? So I have 1 times negative 15, negative 1 times 15, 3 times negative 5, negative 5 times, I just wrote the same thing, negative 3 times 5. Looking at those factors, now I can kind of eliminate, because I know those two factors have to add to 2. So which one of these 4 is going to add to 2 when I add those two numbers? Or which ones do I definitely know it's not?
The last.
That last one, right? Negative 3 plus 5 is going to give me a positive 2. So those are my last two numbers that I need. Also, it doesn't matter if you had the 5 and the negative 3, you'd still end up with the same answers for that. The last thing that you guys can do is just check to make sure your partial products work. So negative 3 times x would give me a partial product of negative 3x. X times 5 is going to give me 5x. When I combine these two, negative 3x plus 5x gives me that 2x. Once I have my numbers, the last thing that I need to do is just write them as binomials. So along the top, that will be x minus 3. Along the side, x plus 5. So that shows kind of that progression from elementary through high school, how we can start with just multi-digit numbers with a rectangular array. Then we can compare that to multiplying two binomials using the same exact process. And then we could bring that in algebra 2 when they are factoring those trinomials, working backwards using the same exact method. Thank you.